Alright, so let's get started.
Okay, so we can index to get single characters. That's fine. We just use square brackets and say the index that we'd like to get the character.
So I'm just trying to make notes, and I'm not just writing down everything. I'm just writing down some basic things like the basic commands or the basic code. Like the basic code for the slicing can be written as the square brackets, and you write the starting index, whatever the number of the starting indexes, then stop, then uh, then step. Okay, so get characters, start at start up to the including stop -1. Okay. Okay, so let's just try this out in the, so let's say I have a variable named nickel, and I want to do slicing, how we are supposed to slice. So let's say there's another variable s, let's assume it to be name, square bracket, and we are starting with 0 and 0 1 2. So let's, and that's a step function, so I'm just gonna leave it, I'm just gonna put it 1 and print s. Let's see what happens. So I actually get ni. So why do I get ni? Because including, so what they're trying to say over here is that they're in, this term is actually stop -1, so I need to add +1 by default. Okay, then save it, run it. I could have just written 3, but just for the convenience I just have to change this number. So let's say how many what's the index of the end? So that's 0 1 2 3 4. Let's put 4 over here, and I'm gonna run. So I get the desired output. Yeah, that's better. Let me just close this. Yeah, that looks perfect. Yeah. All right. Then actually stop -1. If you so if give two numbers, step is 1 by default. If give one number, you are back to the indexing. Okay, I get it. Okay, what happens if I just leave the value? Alright, so by default the Python puts this the step number as to be 1 if I leave it. What if I just, oh, so it doesn't do anything. In the third point it says that you can omit numbers and leave just columns. So if I just leave the columns, so it won't do anything. It just leaves it just leaves the slicing and prints the name itself, the whatever the variable was. Okay.
At We can also slice to get substrings. So instead of getting single characters, we could ask Python to get us a substring starting from one index, going up.
All right, let's try one more thing. So that's 1. Let's start over 1. 1, 2, 3, 4. So that should be 4 plus 1. And I want to leave the step function as that. So I get IKHI. All right.
To some other index and potentially skipping characters. You can take every character along the way. You can skip every other character or some other, pattern like that. The syntax for that is similar to slicing to get a single character. Slightly different though. It's similar in that we have square brackets involved. Slightly different because now we have to give 3 numbers within those square brackets, separated by colons. The first number will represent what's the start index. So where do you want to start your substring from? The second is what's the stop index. So we're going to take every character from that start index, going all the way up to, but not including the stop. Okay? And the step means how many characters do we skip. So if the step is 1, we're taking every character. If the step is 2, we'll take every other character. If the step is 3, we skip every 2 characters, and so on. Now, there's a bunch of combinations we can do within these, with these three numbers within the square brackets that you'll, as you work with these exercises, you'll sort of get the hang of. For now, it won't hurt to always give it a start, a stop, and a step. That's perfectly fine. But something that's really common if you're always going to take every single character is to just omit the step part. So if you just give it 2 numbers, number colon number, Python automatically.
Okay, all right. I'm just trying to get better at learning English also.
Knows that your step will be 1 by default.
Okay, all right.
So you're not skipping anything. Okay? If you're just giving it
Yeah, that's better. Whew. Okay, all right.
1 number, no colons, we're back to the previous slide, right, where we're just grabbing 1 element. And I know this is going to be a little confusing. We're going to look at an example on the next slide. But this is something you'll just have to practice a little bit in the shell with the following example, hopefully, just when you go home, just to kind of make sure that you understand what it's doing. If you have a question, like what if I put in this number or this number, just put it in the shell and see what happens. So let's take a look at a couple of examples. So how do we slice to get substrings? Let's say our string is this longer thing, A, B, C, D, E, F, G, H. When we slice, the first thing we want to look at is the step. Is it positive or negative? If it's positive, and remember if you omit it by default, it's +1. So if it's positive, we're going to work our way left to right, the way we read. If it's negative, we're going to work our way right to left. So what if we index S from 3 colon 6? The step is +1, so we're going to work our way left to right.
D, E, F.
So that means we're going to start at index 3, so that's the D. So we're going to grab the D, and we're going to go up to, get the substring from D up to, but not including the character at index 6. The G, okay? So the characters we're going to grab are the D, the E, and the F, right? We start at 3, we go up to, but not including 6, taking every character because the step is 1. What if the step was 2? So same thing as we just did, except the step is 2. Again, the step is positive, so we're going to work our way left to right. We're going to start at index 3, so we're going to grab the D, and we're going to create a new object, which is going to be the characters D. We're going to skip the E, because the step is 2, take the F, And that's it. We've worked our way up to, but not including the element at index 6. There are some other things, I guess, tricks, or you might want to call them, that you can do. So if we just put an empty colon here, that says just make the same object again. So that will evaluate to just A, B, C, D, E, F, G, H again.
All right.
If we do colon, colon, -1, this is shorthand notation for basically grabbing for me the string backward. So H, G,
All right.
F, E.
So if you put the value of the step to be -1, so it's actually going to evaluate the string in the reverse direction. Oh, that's interesting. So I'm just going to write that down in my notes.
E, D, C, E, B, A, right? Just make the same string as the original one, but backward. And we can do something like this for 1 with a step -2. Now the step is negative, right?
Yeah. So there's actually one thing that I think I've noticed over here is when we are doing slicing over here, the start function, the start number is actually 4. So we are actually starting from E, and the end is actually 1. So we are eventually going in reverse. Okay. All right. I get it. What if I put the step function to be positive instead of -2? Let's see what happens. So let me just open S. So we're going from let's say from 5 to 1. So that would be 1, 2, 3, 4, 5. So it will it should print from. It does nothing. Minus -1. K. Okay. Why is that? Negative of 2. LH. So it starts from the 5. So 0, 1, 2, 3, 4, 5, which is L itself, and goes till 1, which is I. But because my step number is negative of 2, it just prints I. Okay, wait. Let me just add a number over here. Okay. I get it. That's interesting. So 1 minus 1 is eventually. Alright, I see. Negative of 1. But if you're slicing in the reverse, it actually adds 1. So that's why, when we are writing 5:1, it's actually counting values from in the reverse from L to K. And that's why I don't see any I in the output. I see. I get it. That's really interesting.
So that means we're going to work our way right to left. We're going to start at index 4. So we're going to grab the E.
E.
We're going to skip every other character. So we're not going to take the D, but we will take the C.
C.
And we're going to go down to, but not including the character at index 1. So we're going to stop right here.
Oh,
So the characters we took in this order were
I
E
see.
and then C. So this entire expression evaluates to EC.
I get it.
Yes, question. So why do we skip D? Because the step is 2. So when a step is 1, we take every character. The step is 2, skip every other one. Yeah?
For the first one, S3 to 6,
Yep.
why is G not included?
G is not included just by definition. We go up to, but not including the stop. So we'll go up to, but not including the character at index 6. That's just the definition of slicing in Python.
Do I get characters that start up to and including stop long?
So up to and including stop minus 1 means we go up to and including 5. Right, yeah, exactly. Yep. Okay, so again, if you're unsure what a command does, always try. You can always try it in your console, right, the shell, and here's an opportunity to do that.
So let's try to solve this question orally, or mentally. So there's a string named S, ABC. All right. So S, it starts from the 3. So 0, 1, 2, 3. So it starts from this. So it actually starts from this value, 0, 1, 2, 3, and length of S minus 1. So 3, 4, 5, 6, 7, 8, 9. So 9. So it will print till G. Alright. So this first thing will print from this to G, and from 4 to 0. So that's 4. 2, 0. 2, 0, it means negative of 1. 0 minus 1 is negative of 1. So from D to A. From D to A, so output should be from D to A in the reverse. And S is started from the 6. This will not give any output because we just tried with our name. Let's just try this once more. 5, 0. I'm gonna run it. It gives no output. But why is that? Like, why this code does not give any output? The reason you aren't seeing any output is that you're slicing it. Actually, I didn't move back, but you haven't told it to do that way. All right. So like here's what I've learned. When you're actually telling Python to do slicing the backward, you need to mention this step that it's in the in the backward direction. Yeah, so by default the step is +1, move from left to right. Since 5 is already greater than 0, Python is trying to move to reach to 0. It reaches immediately. That's impossible. Instead of crashing, Python returns an empty string. Oh, so it's not like that the Python is not giving any output. It's actually giving an empty string, and it looks like, oh, so that's a very a good thing to notice, that the Python, we are getting an output, and that output is basically an empty string. And it's not the case that we are not getting any output. That's interesting.
So here's a string S, ABC, D3F, and I'm actually going to
So
write this.
I already mentioned what would be the output? It starts from the 3. It means it will eventually start from this blank and till G. And for this, it will start from D, D to A in the reverse. And for this, we won't get any output. We need to mention -1 in the step. Oh, what do you call it? Step function? No, so that would be a very mathematical thing maybe. But okay, step number. Yeah, that sounds better.
This one down, just ABC space, right? There's a space here. 3D, what did I do? Or D3F.
D3F.
And then another space and G.
Wait, my camera just stopped. I need to adjust my camera. Wait, just give me a second. Oh wait, why is that like that? Oh, no. I didn't realize that my camera stopped working. Oh no, that could be a major issue. Anyways, let's just continue.
What do you guys think the first one will be? 3 colon len s minus 1. I'll even do the indices here for you.
So I'm just gonna put the video on 2x, for some time, not for the whole video, because I just have to see the solution for the video.
What's the start? Yeah, the space, exactly. So it's going to be a little space. What is len s minus 1? 10. Yeah, what's the length? How many characters are in here? 11, yep, and minus 1 is 10. So when we do this, when the stop is 10, that means we're going to go up to, but not including the character at 10. So we're going to go up to this H, right? So we're going to take the space, D3F space G, H, and we stop.
But wait.
Yes.
Why do we start indexing at 0 again? It's just
Convention.
Wait. No.
Computer science.
What's the length? So length is 10. We are subtracting -1 from it. But by default, the value of the stop, the stop number is actually the value itself -1. So if I'm putting 10, it means it's actually 9. And I have that's kind of confusing. Let me just try that. So that should be 0. So we are starting over 0. We are going till 5. Okay. Not 5. The len of the name, that is 5 minus 1. Wait, why is that? Wait, no. I see where I got this wrong. So print len of name. So the length is actually different from slicing. I was assuming it to be 10, but it wasn't 10. It was actually 11 in that specific question.
Programming.
I see. So the actual length of the given string, which is ABC, space D3F space GHI is actually 11. So it's 11 minus 1, which is 10, and but the default value of the stop function is actually like whatever the given value is minus 1. So 11 minus 1 minus of 1, so that's 11 minus 2, that's 9. So it stops at 9. All right. So I was a bit confused between the length and the slicing, length and the indexing. Okay, so the length of a given string is not equal to the index. All right. Is it possible? Is it possible that for a given string, the length and the index becomes equal in Python? The short answer is no. Alright. The length always starts at. Alright, so my confusion is over here.
Except for MATLAB, I think they still start indexing at 1.
Okay.
Other questions about this one? Is that all
Never
right?
used MATLAB.
Okay, how about
before.
the next one? S4:0:-1. What's the element at index 4? The D, yep. So we're going to
I'm
grab
sorry.
the D. Are we working our way right or to the right or to the left? Yeah, exactly. So we're going to go up to, but not including the character at index 0.
So D
So we're going to get the D, the
space,
the
C,
C,
B,
the B.
and A.
Am I taking the A?
Yeah.
No, exactly. So that's it.
No?
D space CB.
Oh, my bad. So I was again wrong. Okay. Wait. What was the question? I need to see the question
Yes.
once again.
You want to include the A with the second value be -1.
If you did want to include the A, actually, you would want to do something different, I think. You can't go to -1 because -1 is actually this right here. That's a good question.
That's actually negative 11.
I'd have to try it out, play around with it. But if you want to include it, I think maybe you would just do an empty, sorry, go ahead. You would just probably do an empty colon. And by default, that means the beginning. Yeah, but I'd have to try it out, yeah. How about the last one? Six colon 3. What's the element at index 6?
Wait, I just
Colon
need
work.
to
Okay,
verify
perfect.
if
Thanks
my
for trying it
camera's
out. The empty
working.
colon
Yeah.
works, yeah. If you wanted to grab the A. All right, so S6:3, what's the element at index 6? The F. Okay, great. And we're working our way to the right or to the left? To the right. Okay, so we're going to start here, but we need to go this way. But what's the stop index? Yeah, it's not there. It's behind it. So this last one is actually an empty string. And we can try it with something else too.
I get it.
So if we had this ABC, right? If I'm indexing starting from 2 and I'm going backward to 0, then that gives me the empty string. And the empty string is just quote, quote, with nothing inside. So that means we didn't take any characters in that particular case. Is that right? It's valid. There are no characters in between the F and behind the F. Yeah. Okay, so I'll mention the strings are actually immutable objects, and really a lot of the objects we've seen so far are immutable. That means they can't be modified once they're created. We've kind of seen this already, right? When I draw the memory diagrams, when I create a new object, which is, for example, what's the string version of this integer, or, when I cast a float to an int, things like that, I'm not changing those original objects I've created. I'm just making a new little green box in my memory and reassigning the name. And we're going to see later on in this course mutable objects, which means that once you create them in memory, you can modify them. But for now, anytime you make a change to such an object, well, you can't change the object, right? If you want to get a different version of the object, Python will create a new object in memory, and you can reassign the variable to that new object. So in this example, if I want to
Okay, so strings are immutable. That's a very obvious thing. You didn't create new objects. So f of 0 gives an error. S equals b plus, so since, the Python evaluates the commands from right to left, the S that we see over here is this S. All right. So let me just calculate that in my mind. Starting over 1. So 1 is this A, and L length of S is basically 3. Wait, length of is actually 3. So 1, 2, 3. Okay, but the default value is length minus 1. So in reality, it's actually written len of S minus 1, which is 2. So we are going from 1 to 2, 1 to 2. So bar, bar. Okay. Okay, so I'm just gonna try it. I'm just gonna try this in the Visual Studio Code. No wait, VS Code. Anyways, so what I'm gonna do is name equals this n name. So it starts from the let's say I want everything in small letters, so n plus, I'm gonna remove the first till length of name, and I'm just gonna print name over here. I'm gonna add a name function over here. Clear this up and run this. My bad. Alright. I get it. I get it.
grab, if I have the string car in memory like this, and it's bound to variable s, and I want to change the first letter to a b, I'm not allowed to. Python won't let me do something like, I want to change the letter at index 0 to a b. That's not allowed. You can get new versions of that particular string, so you can do some,
What we are eventually doing over here is we are just overwriting. Yeah. So we redefined the variable s, and we just did some manipulations and overwrite or overwrote, I don't know, whatever you say in English. So we just overwrite the previous variable, which was car, by a new variable that's bar, by doing some string manipulations.
random expression to create the bar that you might want. But then the CAR remains in memory, right? So the CAR will still be there. We're just losing the binding from it.
Yeah, so it's actually in the memory. We are just losing the binding. Yeah, that's the correct explanation for this. My bad.
So any questions so far on these strings? Mostly, they're a new data type, right? You haven't worked with them like you have with numbers, so it's a little bit different. Again, someone had a question, how do you get the A, right, backward? Try it out in the console. I'm happy to answer questions, help you try along with you. But that's what the console is there for, right? The shell here, that's what it's there for. It's just to try quick little things if you ever have a question, what if this or this, and you get to try it out. Now let's move on to some input-output. Right, so far, the programs that we can write are pretty stagnant, right? There isn't much interesting things that we can do with them. There's no interaction with the user. So far, when we've tried to output things, well, you might think we have been out.
Wait, what? Python prints C++ C out. Okay, I know a little bit of. Okay. Am I supposed to laugh on this meme? I don't know. So printing used to output in, okay, 3 plus 2, print many objects are same as, okay.
Outputting things, right? So when we write in our console something like 3 plus 2, Python does show something in the shell, right? This is maybe how we interact with the user. But this is not actual true output. This is, I call this kind of like peeking into the value of the expression. But if you were to write some expression like this in a file editor, Python wouldn't actually print it out. And so here's all the things that we've already tried today, right? We've created all these strings. We've got the length of s, right? We indexed. Anytime we typed these expressions in the shell, Python automatically gave us our value, right? But if I were to type those exact expressions in a file editor on the left here, Python's not actually going to print these out. So this is the file editor. From now on, we're just going to work with files. I'm going to run it by hitting this little green run button or hitting F5. Something happened in the shell. My program ran, right? It says here, it ran this file. But there's no output, right? Where was the length of s? Where were all these indices we've done before? And that's because these aren't actual outputs, right? When we type them into the shell, that was just us doing quick little expressions and the shell giving us quick, that's why I call it peeking into the value, because it's not true output. If you want the user to see output, and the shell is how we're going to show the user output from running a file, we have to explicitly tell Python, hey, I want you to show the output from this expression, or I want you to show the output from this command. And we do this using the print command. So if we take our expression that we want to show the output from and wrap it in a print command, Python will then show that output, and only that output. Right? Can you imagine if we wrote a file that did all these operations and all these intermediary outputs were being shown? That would lead to a really messy file, or a messy program, right? Yeah. And so that's why we have a command where you can explicitly tell Python just the things you want to show to the user. So here, if you want to print the length of s, we can wrap the length of s in a print statement and then run the file. And now the only thing that gets shown to the user is the thing I explicitly printed out, the 3. Right? And then down here, if I want to print this other the result of this other expression, I can wrap that around a print statement, and Python will then print that one as well. But now I'm in charge of showing the user the things that I want to show them, right? Okay. So whenever you have a print statement, Python will print that resulting expression and then enter a new line. So as you saw here, we had 2 print statements, one around len and one around s at -3. And Python put the result of these expressions, each one on a different line. Sometimes you might want to have expressions on the same line, or the results of expressions all on the same line. So we can do that. We can put all of these different objects within the same print statement. Okay? We separate them by a comma within the print statement. That's down here. Python will print all of our objects, no matter what types they are, and it'll separate each object by a space. So there's my...
So you can see over here that it says that print a plus b plus c is an error. So, the reason why it's an error is because you're actually trying to add a integer, a data type integer, and a string, which is, it's not possible. It would be valid if we apply the multiplication operator over here, so that won't give us error. It would just, so if we would have just written that a star 3, so it would have just printed the 3 times, or mosquitoes over 3 times. Yeah. So that's the reason it's an error.
object there's my object, the number 3, and there's my object, the string musketeers, and it printed it all on one line with a space in between them. And that's what this comma does. It automatically inserts the space.
Okay.
Now let's say you don't want to...
That's a new thing that I've learned, that in the print function, you could actually separate the values by commas, and it automatic wait. Okay. So let's say a equals wait, why does this give me an error? Print a plus b. So there won't be, as far as I'm able to relate, that there won't be any spaces between. Let's just run this. Yep. Comma b, if I don't put a space, there won't be any space. Oh, there is indeed space. So Python actually automatically puts space, regardless of if I put a space between a and b or not. I see. What about putting spaces between the addition operator? Okay, I get it.
Space for whatever reason. What if we try concatenating these objects together? Right? Remember we saw concatenation. We said it doesn't automatically insert spaces. It just kind of merges the strings together.
What was concatenation? What does concatenation mean in Python? Combining data structures like strings, list. Okay, so I get it.
And we run it. Well, I kind of already gave it away. It's going to be an error. But let's see the error. It's a type error. It says, can only concatenate strings, not integers, to strings. All right, makes sense. This is a string. This is not a string, so that's not okay. And this is a string. So instead of concatenating different objects together, we now have to remember to cast every object that's not a string to a string. So this line is exactly the same as the previous one, except that b, which was the number, the integer 3, is now being cast to a string. So I'm wrapping the b around the str. And that casts my integer to the string. And now Python is happy to concatenate these 3 strings for me. Okay, that's basically what I said. So that's output using the print statement. Now how about input? We can get input from the user, not surprisingly, with a command called input. The format of input is usually like this. So we have the input command. In the parentheses, we give it a string. And then we usually want to save the input to a variable. So the next few slides are going to go through step by step what happens when I have these two lines of code. Text equals input type anything, and then I'm going to print 5 times text.
So I need to check one thing over here. So text equals input anything and print type of text. Because the data type is not specified over here, I just need to anything. So ABC, that's a string. Okay, let's run the program once more. 3. It's okay. So by default, if I'm not using any data type over here, the input will always be string. Integer okay. What if I try to anything, let's say Nick? Okay, so now I can only input an integer, not a string or any character. Okay, let's just run this. Alright, so not anything, only integer.
So when Python sees a line that says, input and then some string, Python will automatically take the string within the input, right? So in this particular case, here's my input command. The string inside the input is type anything : space. On the shell, Python will put that string for you. And then it will wait. It waits for the user to type some stuff in and hit enter.
Okay.
As soon as the user hits enter, whatever the user typed in, so let's say the user typed in howdy, whatever the user types in will be saved as a string, sort of replacing this input statement. So you can think of the input kind of like an expression. It's a weird one because it's waiting for the user to give us something, right? But in the end, the input gets replaced by the string version of whatever the user typed in. So the user can type in something, numbers, letters, characters, anything. As soon as the user hits enter, whatever the user typed in will be saved as a string, replacing this input. So in memory, the way this looks like is this is our memory cloud. Here is this object that I've created, which is the exact characters the user typed in. Okay, well, if the user typed in howdy, then what does this line end up being? Text is equal to the string howdy. And that basically is what we've seen on the previous 2 slides, right, when we've worked with strings. We're going to assign this variable and bind it to this particular string of characters. Now the next line is easy, right? We're going to print whatever the result of repeating text is 5 times. So the print will show on the shell, howdy, 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 right? That whatever the user typed in 5 times. Okay, let's look at another example. In this particular one, we're going to ask the user for a number. And I want to print 5 times whatever the user types in. So num1 will again grab input. So what we're asking the user to do is to type in a number, right? So when the Python sees this, it prints type a number and then waits for user input. Let's say the user types in the number 3. That gets saved as the string 3. Again, so no matter what the user types in, it's being saved as a string. Even if it's a number, it's being saved as the string, that number, right? So to Python, it's a character. To us, it's a number, but to Python, it's still a character. So num1 in memory basically becomes the string 3. Just one single character, 3. When I print 5 times num1, what is that going to look like? You guys tell me.
5 times, wait. So input, so that should give me 3 for this specific output. the Python program will eventually give me 3333 because the 3 that we give as an input is not an integer, instead it's a string. But in the num2, what we can see over here is that the input that we are giving to the program is actually an integer. So integer times, another integer will eventually be an integer. So 5 times 3 is actually 15. Yeah. So uh, yeah, I think that's all the explanation that is required for this specific slide. Okay.
Times num1, what is that going to look like? You guys tell me. Exactly, right.
333, yeah, yeah.
33333, right? Because we're working with a string here, not an integer.
Yeah. But what about
If we want to
num2?
work with an integer, we have to wrap our input statement with a cast statement, right? So again, this is what Python does. We can combine expressions together. In this particular case, we're going to combine the...
Hey, look at the guy. He's running. Wait, what are those? Are those chocolates? I don't know. Yo. Uh, anyways.
casting the input with the input statement. So now the user can type in for me 3 again. The input itself is going to be the string 3, but that line becomes num2 equals int parentheses string 3, right? And that I did it on the shell a little earlier today, right? When we cast a string to an int, it becomes the number that int. So num2 is then going to be 3. In memory, num2 is not the string 3 anymore because we've cast it to 3. So when we print 5 times 3, we're doing the mathematical operation 5
Yeah.
times 3, right? 15.
Let me just check the recording. Yeah, everything looks fine.
Okay. Let's have you
Write a
code.
program that asks the user for a verb. Prints I can dash better than you. Where you replace I can run better than you. Okay. Okay, alright. So I'm gonna try this program in the VS Code without looking at the solution. So we need, let's say, a equals input, enter a verb, and then print I can a better than you. So let's just run enter a verb. So I can learn better than you, and then what it does is, so what I'm actually thinking, defining, we can actually solve this specific problem in many ways, but I'm actually going to define another variable for solving this problem. So b equals this plus a, okay, and then print out, I need a b times, how many times? 5 times in a row. Save, enter a verb, sleep, 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 sleep. I can sleep better than you. But then we actually got a space over here. We need to remove this specific space. What can we do for that? If I just remove this, um, play, play, play. But we don't have spaces. What can we do? Okay, let's just look at the solution.
So I'm going to give you a couple minutes. I'm going to have you write a program that is interactive. So it's going to ask the user for something, and it's going to print something back to the user. So we're going to ask the user for a verb, and then I want you to print 2 things for me. The first is whatever the verb that user typed in, you're going to write I can whatever better than you on one line. And then on the next line, so with another print statement, I want you to print that verb 5 times. So if the user types in run, you're going to write I can run better than you. And then on the next line, run, 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 run. So the way these you try it's work is I actually have some space here. I've already pre-written the instructions for you. And all you have to do is fill in the code. Okay, so I'll give you a couple minutes, and then we'll write it together with suggestions from you, and we'll see how far we can get, and we'll definitely finish it together. So you don't have to finish it under. Yep.
It's supposed to have like a file that we write this in, or do you just try on
You should have this file. It's part of the zip file you downloaded for today.
oh, here it is.
Yeah. All right, does anyone have a start for me? So how can I ask the user for input? Yeah. Yep, that works for me. And I'm adding a little extra space here between the colon or whatever prompt you have, just so that when the user types it in, it isn't right beside the colon or the end of your the end of this string. So as soon as we do this, the program will wait, and the user will get to type something in. What's the next step? What's the first? How can you use this this input?
To print.
Yep. Let's print something. I can in quotes. Yep, I can.
Would you like outside of the quotes put the question continue?
Yep, we can put question. Yep, exactly. I can question, comma, because it's another object, and I'm happy to put a space in between it. I can question, and another string better than you.
Better than you.
There. And we don't need to write the full program right away. We can just test this a little bit out. So choose a verb, run. The one I gave you is print. Fine. That looks good so far. All right, so then we can keep working on the second part. How can I print that verb 5 times? Yeah.
Print and then question times 5.
Print question times 5. Okay, let's run it and see what happens. Run. Not quite. I'm missing
Ooh,
spaces. This is an
okay.
awesome start. How can I add the
Okay.
spaces in there?
Okay.
Yeah.
Okay.
The verb plus like quotes in the space.
In parentheses, yep, we can concatenate it with a space, exactly. Times on all that times 5, yeah. Let's try that.
Oh,
Run.
we can. Oh, all right. So all I was supposed to do, add what do you call it? An empty string right after the A. So before that, I actually added that empty string before A. So enter a verb. So lift. Let's say I can lift weight better than you. Lift weight. So okay, let me just clear this up and run this program once again. Enter a verb. So I can score better than you. Score. So if you actually look at the output, there would be an empty string right over here. There should be an empty string right over here. Okay, I see. So it's all about representing the output visually. Okay.
Yep, that looks pretty good.
Yeah.
I do want to mention one thing. There is one improvement we can make to this program. If we look at the output here, the thing that we're actually printing out is this verb space, right?
Space. Yeah. Right.
There's 1, 2, 3, 4, and the last one actually prints it with a space at the end. So a challenge for you, and the answer is a little bit lower. I
Okay.
provide you guys with answers to these, but a challenge.
Okay. So we could actually do slicing. Oh. Wait, can we store? Can, I just have this doubt. Is it possible? Is it possible to? No, I don't have to do that. Okay, so I could eventually store C and then print C. I need to do slicing from it starts from the 0 and len of C. Yeah. Add a verb. So okay, I have a doubt in this SPE's specific code. Does the output contains a empty empty string like it does contain in the code below? So by default the stop function stops at the last index -1. Okay, run. Is exclusive before that number. Wait, uh, you know, I was actually thinking that the okay, it should give C. Okay, so should should I add should I add len of C -1 for removing that empty string in the end? Yeah, my point is to remove that extra space that comes after the run in my code. Okay, I get it. Negative, let's just try -2 into a run. Okay, so it should be -1. I was just testing. Sleep. I can study better than you. Study, and I get it. Where's my lecture?
Challenge for you is think about how you can change this last print statement so that this last run doesn't.
So that's the whole point of slicing. that's one of the applications that we can use, one of the applications of slicing that we can use.
Actually have that extra space. Right? Just think about it. You don't have to do it right now. Okay. So with what we know so far,
An important algorithm, Newton's method, find the roots of the polynomial equations such that a function f, which is a function of g and x, can be given as gq minus that equals 0. Algorithm uses successive approximation. Next guess equals whatever the previous guess was, minus f of guess by f dash of guess. Okay, all right. So f dash is nothing but the derivative of the function f with respect to what? Is it g or is it x? Because if it's g, then it would have a different value. If it's x, then it would have a different value. The partial code of the algorithm gets the input and finds the next guess. Cube root of, okay, start with current estimate.
we can actually apply some of these ideas to a more numerical example. So Newton's method is a way.
Wait, what time it is? It's 4:46. Okay, so we have 9 minutes left and I have to go to the gym, but I'm not gonna go to gym until I'm gonna complete this.
To actually grab the roots of a polynomial numerically using this idea called successive approximation.
Alright.
We can't actually write the full algorithm with what we know so far, but we can write a really important part of it. The part is the part that we can write is the one that gets a next guess based on an initial guess. So you don't need to understand how the algorithm works, but basically the next guess based on an original guess looks like this. This is the formula. So the next guess is the original guess minus, and we evaluate the formula for whatever polynomial we want to find at the original guess, divided by the derivative of that.
I need to write that down. I could actually see that when I took notes for the lecture 1, it was consisting of 2 pages, but when I start taking notes for the lecture 2, I just have filled up just half of the page. That's it. And that's crazy. It means, as we proceed in the lectures, as we further proceed into the lectures, the more practical we are getting. I see. So, successive gq minus x that equals 0.
Function at the same guess. So here's just some code. We've got asking the user for input, what x do we want to find the cube root of? Then we ask the user for input, what guess do you want to start with? And then we can just print the current estimate cubed. So we just guess cubed. And then the next guess is just following the formula up here, right? The next guess is going to say it's my original guess, so the g that I read in from the student, or from the input, minus, and now I have a division. The top of it is going to be f at g, right? And the computer is not evaluating f, right? We have to actually write down what the formula is. The function is, we want to evaluate at g, so it's g cubed minus x, that's our function up there, divided by the derivative. And again, program is not going to evaluate the derivative automatically. We're going to tell it what the derivative is manually.
Alright.
So, you know,
Okay.
the derivative of g cubed minus x is just 3g squared. So then we just kind of hard code that.
Alright, so the x is actually constant, not a variable over here. I get it. So we are differentiating this f with respect to g. Some mathematical stuff, you know. I'm just I would love to do mathematics. I'm just bored of learning CS.
And the next guess to try is just going to be that particular division and subtraction. I'm sorry?
Sorry, there's no function for to take a derivative.
I'm sorry?
Sorry, there's no function for to take a derivative. There's no command.
There are Python packages that allow you to do that, but for our purposes, we're just going to hard code it in this
Alright.
case.
So let's say we are given a function f that equals g q negative of x, but you know the Python is actually giving me an error because it does not know what g and x is. So x is equals to integer. Let's say it's going to be input, enter any number, and let's say g equals an integer. I'm just defining. So f dash can be written as 3 times g square f dash or f prime. So that's how we are actually supposed to manually we manually need to tell the Python that there's a derivative, that f is a function and f prime is basically a derivative of the function f. Okay.
But yeah. So the way this looks in code is as follows, right? That's exactly what we had in there. And if we run this program, all it does is, let's say we want to find the cube root of, say, 27. Let's start with, I don't know, 5, right? It tells me that 5 cubed is 125, way too big, obviously. So the next guess to try is 3.69, right? And that's all the program does. It doesn't take this next guess and do another guess. We haven't learned how to do such a thing yet, but we will in the next couple lectures. One other thing I want to mention is this thing called an F string. It's something that became available, I think, a couple years ago in Python with Python 3.6. It's a way more convenient way for us to print out mixtures of literal text and resulting expressions. So if you have a bunch of complicated expressions you want to print out, an F string is the way to do it these days. What we know is these first 2 lines. This is what we've learned in the past couple slides. So if you want
Alright. What are F strings that came in Python 3.6? Bro, what's wrong with you? Formatted string literals are widely considered the gold standard for putting variable strings when used to make a code more readable, faster, and less prone to errors than the older methods. Okay. To create an F string, you just simply put an F before. Okay. Okay. Wait, so that's my editor. So name equals F. Alright. Okay. Alright, so print, then I'll use curly. My name is, then I can just write name. TRO, intro, and I'm gonna define intro equals okay. So this whole thing needs to be in quotation. No, wait, what? Name, let's just change this to name 1. Oh, I see where the problem is. I get it.
Wanted to have, these two values
Let's just complete this up. What's the name? Okay, it's 5.
and print, this big number is whatever fraction percent out of the original number. If you actually run this in the Python file, you'll see that this comma here puts an extra space between my number and the percent, right? And that doesn't look very good. When you have 3%, you're expecting the percent sign to be right by the 3. But this comma adds for me an extra space, so it looks a little bit weird. Which means that our solution was to cast things to strings. So if we wanted to have that percent sign be right beside the number, we'd concatenate this cast with the percent. But F strings allow us to do this all in one. So there's no concatenation to think about. There's no casting to think about. F strings basically are this F and then a long string.
Mm-hmm.
And it's a mixture of expressions and things that I want to print literally.
All right. So that's an amazing thing. The F strings, definitely one of the amazing things that I've seen.
To the screen. So the thing that's not inside a curly bracket are all things I'm going to print literally to the screen. So the space is space, and then later on percent space of percent.
How long we have been recording? We have been recording since 58 minutes. No, I actually stopped the recording in between because my camera stopped working for some reason. Anyways.
Those are all things that will literally be printed to the screen. anything that's within a curly bracket is considered an expression in Python. And so before Python prints out the thing to the screen, it's actually going to evaluate whatever num times fraction is. And it knows these are going to be variables. And then later on, fraction times 100, and then later on num. These are all variables or expressions that it will evaluate before actually putting them on the screen. And now notice these expressions we might have had to cast to strings beforehand if we wanted to concatenate them, but now we don't because they're in this special format with the curly brackets of the F string. So just something to practice. I'll interchange. I'll use sometimes this. I'll use sometimes casting. I'll use sometimes F strings. But if you can use F strings whenever you can, that's really the way to go in Python these days. So the big idea, actually, even with F strings, is that you can place expressions anywhere, right? We placed expression, I forget here, where we indexed. We placed an expression in the index, right? Now we're placing expressions inside print statements, and now we're placing expressions inside F strings. So expressions can be placed really anywhere, which is pretty awesome. Very versatile. Python will just evaluate them and then just move on to the next lines. Okay, so the last topic of, I'm sorry, any other questions about the inputs and outputs? Or is that all right?
No, not really.
Okay, so the last thing, right. Okay, so the last thing that we'll talk about today, and we will.
Wait, is everything okay? Yeah.
We'll maybe talk a little bit about it next time, is conditions for branching. So right now, the kinds of programs we can write are basically very linear. We have a bunch of lines of code, and they get evaluated one by one. There's no way to skip around. There's no way to repeat things. There's no decision points in the programs. The values that you get are just the values that are in the program. Now we're going to look at ways that we can add decision points in our program. So if some if some variable value is less than some other variable value, we want to evaluate some code. And otherwise, we'll do some other code, right?
Okay.
So some code can now be skipped in programs with this new idea. Before we go on to showing you exactly how to do that, I'm going to talk about another notion of equal in programming. And this might be more the notion of equal you might be used to in math. So the first notion of equal is the one we've already seen. It's assignment.
Yeah.
It's done with one equal sign. The value on the right-hand side is bound to the variable on the left-hand side, right? That we know. Double equal in Python is how we tell Python that we'd like to know whether these two expressions are equivalent. Sorry, not equal. So if we're going to be looking at equivalency, how do we express equivalency?
Boolean.
Well, if something is equal to something else, we
True.
can say yes or no. We can say true or false.
True or false. Boolean.
True or false should ring a bell. It's the Boolean data type that we saw last lecture. And so now that we're going to show you equality or conditionals in programming, we're going to start talking about Booleans a little bit more.
All right.
So expressions don't just have
Things are actually getting interesting over here because we just, completely changed the topic.
to be numerical. Expressions can actually give us Boolean results. So for example, an expression like 2 less than 3
It's true.
is okay in Python.
Yeah.
And this expression actually evaluates to a certain value.
True.
It's not a number, it evaluates to true. The Boolean value true, because yes, 2 is less than 3. The equal sign here, this notion, with a double equal, is how we ask Python to tell us whether two things are equivalent.
Equivalent
And
or
this will be the
False.
Boolean value false. So here's a bunch of other operators that we can run on any type, really, in Python. Most of the time we're going to run them on numbers, but they can be run on strings and things like that as well. So obviously the double equal sign checks for equality. So if I is the same as j, this entire expression is replaced with true. And if they're not equivalent, this entire expression is replaced with false. Okay? If we want to check for inequality, we use not equal, so exclamation mark equal is means not equal. So if the number I or whatever object I is not equal to object j, then this entire expression is true. If they are equal, then the entire expression is false. And then of course we've got the less than or equal to, greater than or equal to work with as well. We can apply these to strings, and with strings it's important to be careful
March is not equals
about case. So for example, lowercase a equivalent to uppercase a is false, right? Because they are not the same character. Now that we're talking about Boolean operators, we can actually start to combine them together. So if I have the expression, for example, 2 less than 3, right, like I wrote on the board.
So my camera stopped once more again. I don't know why. Alright, so my phone just died for some reason and I need to charge it. Alright, so we have to continue without the camera since my camera died. Okay, let's just continue without camera.
That's true. But I can combine that expression with another one. Actually, by itself, I can say what is not 2 less than 3, and that will be false, right? It's the opposite of it. But I can also combine Boolean expressions together. So I can say what's 2 less than 3 and 3 less than 4.
True.
So 2 less than 3 is true, right?
And true.
And 3 less than 4 is also true. So the combination of these two Boolean expressions is what is true and true.
True.
True. Right? So if one is true and the other one is true, then both of them together are going to be true. If one of these is false, so is 3 greater than 4 is false, well, what's false and true?
False.
It's going to be false. So if one of these operators is false, then the entire expression is false. And you don't have to remember this truth table. You can always check it like I just did right here in the console. But at a high level, right, when we're doing the AND operator between two Boolean expressions, we need both of the expressions to be true for the result AND to be true. The OR is the other one we can usually do. The OR is always true, except for when both of the operators are false. Right? And it kind of makes sense in English too, right? If either operator is true, then the entire result is true. But when both are false, the OR of both of them is false as well. So here's a little example where we can use these operators in Python. So we can draw the little memory diagram as well. So pset time is 15. There's my variable. Sleep time is 8. There's my other variable. I'm going to print sleep time is greater than pset time. So here my print statement is going to grab that expression,
False.
which evaluates to
False.
false. 8 is less than 15 is false. So that's going to print false. And then I have two more variables. These ones just happen to be Booleans. Derive is true, drink is false. So drink and derive is going to be false because one of them is false. Okay. And so here I've got this other variable both, and then I'm going to print false to the console. Okay, quick you try it for you guys.
So write a program that saves a secret number in the variable. So secret variable, what do you mean by that? Okay, so SV secret variable is input, and enter a secret variable number, sorry, S. So let's just secret number. Take, all right, so G is equals input, guess that number, why are we not using integer data type? Print secret number, so that's 10. Guess that number, 10. True.
So let's have you write a program that saves a secret number in a variable. Okay, so that's going to be your program's secret. Presumably people using your program won't be looking at the program itself. They'll just be interacting with the program in the shell. So save a secret number in a variable, ask the user to guess a number, and then print either true or false if it's the same as your secret or not. So it's here. In this, you try it down here. So you can start with something like secret equals, and then put your favorite number there, 5, whatever, and then write the rest of the code. So ask the user to guess a number, print a Boolean depending on whether the guess equals this secret or not. So I'll give you a couple minutes to write that. Yeah, sorry. If you use the symbol and, it's not the same. You have to actually type out AND in Python. The AND means something else. It's like it's an operator with the bits of the number. So something, it's not going to give the same answers. Right, you're thinking about Java or C++ or something, right? Yeah. All right, does anyone have a start for me for this program? How do I grab the user input? Guess equals input. Yeah, we can be nice. Please, yes. What's that? We want the user to give us an integer, yeah, a number. Exactly. So, okay, yeah. If we leave it like that, then we're just grabbing the string. So we have to cast it to an integer, exactly. Now what? How do I check for equivalency between my secret and the guess? Secret equal guess.
Equal guess.
And you want to print this? Yeah. Let's print that. Okay. Run it. Let's guess something that's not the same. False.
False.
Run it again. Let's guess something that's the same. True. And we can guess something that's lower too. Just. Is everyone? Yeah.
Did you assign, like, for some different program, did you assign the secret equals yes to a container or something?
Yep, exactly. Equals this thing. Yep, and then you can, do whatever you want with that. Print equal or something. That's the same, but yeah, you can do other things with this variable. Yeah. Exactly. 5. Yeah. If you want at home, try to see what would have happened if you didn't cast it to an integer. See if the program would have crashed or not, or if it would have just, worked but given a wrong answer. So why do we do Booleans, right? Booleans are important variables because they allow us to start thinking about writing programs that make decisions, right? The way we talk is, we can say something like, if this is true, do this, otherwise do this. The Boolean part is if that something is true, right? So the something is true is going to be the Boolean that we can create in our programs. And then the do this is some sort of commands, and then the otherwise do that is going to be some other set of commands, okay? So a really simple, Boolean expression could be, it's midnight, you get a free food email, do you go get the free food, or do you sleep?
Sleep.
Right, that's the very simplest kind of decision point.
I get the food, because I'm hungry all the time.
You can make. But with conditionals, you can actually write a pretty cool program that gets you to that free food, right? So let's say this is a map of MIT. This is where you are. That's where the free food is. Okay? We can write a really simple algorithm using just conditionals that takes you to that free food. So the algorithm goes like this. So I'm going to say, I'm going to walk always in this direction. So I'm either going forward, backward, left, and right. I'm not turning. And I'm going to say the algorithm is always going to have my right hand be on a wall. So if the right is clear, so standing here, my right is clear, so I'm just going to keep shimmying until I reach a wall. If my right is blocked, but my forward is clear, I'm going to keep going like this all the way to the end of this, the room. If my right is blocked and my forward is blocked, right, as if I would have reached the end of the room, I would have gone to the left. And if my right, forward, and left is blocked, if I'm over there, I would go backward, right? So I'd go backward. So basically, starting from here, I've made my way all the way around this room, and I would go out the door, down the hallway, right? And if the map of MIT doesn't have islands, so if the free food isn't somewhere sort of in an island in the middle here, if it's just a regular old maze, I would eventually make my way to the free food, following this really simple conditional algorithm. So how do we actually do conditionals in Python? How do we tell Python, hey, I want to insert a decision point right here? We do that using the keyword if. And the if starts a decision block. Now the simplest decision block is just an if by itself. So if Python sees that if, so there's some code that it's following, and then at some point it reaches the if, the condition tells Python to check whether that condition is true. If the condition is true, so this is our decision point, then I'm going to deviate from my main program and do the code that's part of that condition. Those, I guess, 2 lines, ... inside there. If the condition is not false, I'm not going to go that route, and I'll just keep following the rest of the main program. How does Python know how many code lines to execute that's part of that condition? Well, it looks at the indentation. So notice here I've kind of put a few spaces for these 2 and ... code blocks here. Anything that's indented right after that if statement and that colon there is a set of commands that are part of that block. So anything here will get executed all at once. And that's a really simple if. Either you do this set of commands, extra commands, if the condition is true, or you don't. Now you can add an exception to that. So if the condition is true, again, we're following the program, we reach this if conditional here. If the condition is true, again, we're going to deviate from the program and execute this other set of commands right here. Otherwise, the condition is not true, and we're going to execute this other set of commands over here. So these guys over here. So either we do this set of commands or the other set of commands, but we never do both, and we never skip both of them. So either we do one set or the other. When we're done executing all the indented blocks, part of the condition or the other one if the condition wasn't true, then we rejoin the rest of the program and continue executing. So this is all, the rest of the program is at the same indentation level as our original if and else. We can add a whole bunch of conditions, right? Not just an if, do this, otherwise do this. We can actually add a bunch of things to check using elif, which basically stands for else if another condition do this. So here's our program. We reach a decision point. If the condition is true, like before, we'll execute this set of commands. But otherwise, the condition is not true. We're going to check another condition. Else, if this other condition is true, we'll execute this other set of commands. Otherwise, here's another else if. We'll check another condition. If it's true, we'll execute some other set of commands. Otherwise, there can be more elifs. And at some point, we're going to rejoin the rest of the program. Now, these elifs are going to be, each condition is checked one at a time. The very first one that's true is the one that gets executed. We're never going to execute more than one, right? Because this is an if, else if, else if, else if. So even in English, you're only going to do one of these, right? You're never going to do all of them. It is possible to skip all of them, though, because if none of those conditions are true, you just don't do any of them. If more than one is true, you do the first one that is true.
All right.
If you want to have sort of a catch-all kind of version of the middle elif, 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 you just add an else at the end. So if none of those conditions are true, you can add an else, which says you just do this if nothing is true. Okay, kind of like what we had over here. If this one, otherwise do this. Well, if any of these conditions are true, do one of them, otherwise do this thing. Okay. So here's an example. We've got peace at time, we'll just put some variables in there. Sleep time, we'll put some variables in there and run it, see what we get. I've got one code block here, an if, elif, and an else. So the first code block, the condition is it checks that the sum of those two is greater than 24, and it does something. This is the block that's part of that condition. Notice it's indented by usually 4 spaces. Elif, so if this one was not true, then I'm going to go ahead and check the next one. The next condition is that the addition is greater than or equal to 24, and then we're going to do this print statement here. And if neither of those are true, I'm going to do whatever is in this code block here. I'm going to do these 2 lines. Okay, so this is my sort of, I call it a catch-all because none of those other conditions were true, so we're going to catch ourselves and do this print, do these commands here. And otherwise, once we finish doing either this one or
End of the day.
catching whatever
Yeah, so my day is also going to end in 11 minutes and 15 seconds.
is left over in here, we're going to evaluate the print statement here, and we're going to print end of day. Because this is the rest of my program, notice it's at the same indentation level as my original program. So here is this program. So if peace at time.
You know, actually, I don't really have to write that because I think I'm pretty much aware about if else and elif statements in the Python, so it's gonna be totally fine if I don't write that in my notebook or in my notes.
Sleep time is 22 and 8, right? The addition is more than 24. So this is going to enter this code block here and print impossible. If it's exactly equal to 24, right? So 22 and 2, we're not going to enter this one, but we will enter this one, right? Because it's exactly equal to, it's not greater than. So then we're going to print full schedule and then rejoin the rest of the program here and print end of day. And otherwise, if this is something low, right, less than 24 and not equal to 24, right? So neither.
You know, so none of these 2 blocks will evaluate because the condition says if, only if. So this print will only come if this is true. This print full schedule will only come if this specific condition is true. But since none of these conditions is true, we are going to jump over the else statement. So leftover is equals to abstract. I don't know what that is. I'm assuming it to be its abstract function, but I don't really remember what it does. That's 24 minus p set, so that's 14. So 10 leftover is equals to free time. Okay, so 10 hours of free time.
Either of these conditions are true, then we're going to enter the else, and we're going to evaluate or run these 2 lines of code here. So the 2 lines of code here are going to grab the absolute value of 24 minus the p-set time minus the sleep time, figuring out how much time we have left in the day.
10 hours.
It's also going to print this line here, and
Yeah.
then rejoin the rest of the program to print end of day. Okay.
Fix this buggy code if this equals x is the same as y. Enter a number for x. Alright. So, this print statement doesn't make any sense. Because let's say you put x equals 1 and you put y equals 2, then this code will not execute, but because we will come out of the statement and we would jump directly into this print statement, which will evaluate, and it would say that these are equal, which would be wrong because mathematically 1 is not equal to.
Quick check. Nothing to run, nothing to write here, nothing to run. Think about this program. What is wrong with it?
That print statement.
So I'm grabbing a number for x, a number for y.
This print statement should be inside, and if x and y are not equal, then this program will give no output.
And then I'm checking if x is the same as y. I'm printing x is the same as y. So if I give it 5 and 5, I'm going to print 5 is the same as 5. And then I'd also like to print these are equal. What's the problem with this program? Yeah?
If x is not equal to y, it's still going to print these are equal
Yeah.
because it's not indented.
Exactly. If x is not the same as y, we rejoin the rest of a program because the indentation level of this print statement is the same as the rest of our program. So how do we fix it? Indent. Yep. We'll just indent that print statement in to be at the same level as the if statement. So we can actually nest indentation statement. We can nest conditionals, right? Because once we've created a conditional, it's just a code block. So here I've got an if statement with its own code block. And inside that code block, I can actually have more if statements that are just going to be executed whenever this condition is true. So this is the inside code block. So for example, the place where we would execute this inner code block is when x and y are equivalent. Just block condition to be at the same level. So we can actually nest indentation statement. We can nest conditionals, right? Because
so nesting is basically putting, a conditional statement inside a conditional statement. So what we can see over here is that x equals float. Okay, so x and y are two float data types, and if x equals y, so let's say x equals 1.0 and y equals 1.0, then this specific block of code will execute, print x and y are equal. If y not equals 0, and print therefore x by y is alright. Okay, so we have another condition that, okay, I see.
once we've created a conditional, it's just a code block. So here I've got an if statement with its own code block. And inside that code block, I can actually have more if statements that are just going to be executed whenever this condition is true. So this is the inside code block. So for example, the place where we would execute this inner code block is when x and y are equivalent, right? Because then I'm going to enter this code block here. This is true. I'm going to print x and y are equal. And then this second conditional here, y is not equal to 0, is also true.
Am I recording?
And then I'm going to print this one as well.
Yeah.
Right? I've already done one of the conditionals. They're true. So I'm going to skip the elif and skip the else, and I'm going to rejoin the rest of the program. All the other cases, right, when one value is different than the other, will either take me here in the else and then rejoin the rest of the program, or when they're equivalent, I'm going, or here. I don't actually have a case for that one on the slide.
If let's say if both are 0, only this statement will get output. I'll only get this thing as output, that x and y are equal, but this specific block of code will not execute since y equals 0.
But when they're equivalent and y is equal to 0, I'm not actually going to enter this inner conditional, right? Because
True,
while x and y were equivalent, which is true, y was equal to 0. So that not equal to 0 is false. So it's just backward. And then we rejoin the rest of the program. Yeah?
What did you do the float for?
Oh, I'm casting the numbers to floats. I could cast them to ints as well. Yeah. Yeah. Just so I'm not comparing strings. Yeah. So now that I've introduced conditionals, it's important to do a little bit more practice to get a mental model of how to trace the code, right? And the visual structure of the code actually helps a lot. And Python is unique in this sense. There's no other languages that actually force you to indent things. So the other languages don't really force you to have this visual structure to match exactly what's going on. But it's actually really useful in Python. That's what I like about Python. It just helps you see things that are going on immediately. Like, this set of code is part of this code block. And so it helps you kind of debug a little bit more efficiently. But the more practice you get, the more you'll get used to kind of tracing the code and knowing exactly, if these variables have this value, exactly where your code is going to go. So I'm going to skip this, you try it, because it's just kind of you tracing the code. And I'm going to have you do this one, or we can write it real quick, or you can start and then we can write it together. It's a variation of the program you just wrote. Instead of telling me
are same as a secret. So let's try this. If the Sn minus g is greater than, so I'm just gonna print difference is too big, else if minus g is greater than g, not g, it should be Sn. Wait, lf, yeah. Difference is low, it's too low, else elif if Sn equals print both are same. Integer okay, wait, so let's say that secret number is 10, not 10, it's 20. I'm gonna run the program. Let's say it's 16, difference is too low. So that's 20. Okay. Oh, my bad. It should be greater than. So what wrong I did? I'm just getting some brain fog and I'm not able to think much, but I'm just gonna do this anyway. So Sn was 20, 20 minus G, which was my 100. Okay, anyways, just
Whether
look
the
at
guess is
we are just gonna look at the video.
true or is the same as the secret number. I just want you to print whether the guess is too low, too high, or the same as the secret number. Okay. So we're going to need to put a conditional in there. If some conditional, we're going to print something. And yeah. So I'll give you about a minute, and then we can write it together, and then we can be done. Oh, yeah.
Two if statements in the program.
You can have two if statements in the program, yeah. And there's actually some exercises I have for you guys to try at home here where there are two if statements in the program. And just to see what happens, that starts two conditionals. So if you have if some conditional, that one can be true. And if some other conditional, that one can also be true. And then both will be evaluated. It's not an else situation, right? Yeah. That's a good question. So I'm just going to copy the input from before. Does anyone have a start to my conditional? I just copied what we had before for the input. Yep.
So, if text is greater than
Yep. Yep.
right?
Print. Yep. Too high. Good. Yep, that's a great start. So we can even run it and, guess something that we know is too high. Perfect. Too high, yep.
So what I'm gonna do, I'm just gonna understand this and I'll try this later because I have to get to the gym right now, So yeah, let's just complete this thing up.
Next.
We are just left with exact 4 minutes.
Do you want to do an else or an elif? Yeah.
Actually, I would get rid of the equal sign because if we print a 5 now, it would still say too high.
That's a good point. So if we run it now, let's run it with a 5. It says too high, exactly. Yeah. So let's remove the equal sign. It's a good thing we debugged that. So we can do an elif. The guess is equivalent to the secret. And then we can print equal, right? Oops. Does everyone understand why we removed that equal sign from the greater than? Yeah? Because we would have mistakenly gone into that first path. But elif, we can have a case where the guess is equivalent to the secret, sure. And then we'll print equal. And then the last one can either be an else, because we know the only other option is guess is less than, or we can do another elif if we want to, but we can leave it as an else. And then we can print too low. And then we can run it, and we can guess all the variations. So something that's too high, something that's the same.
Okay, so eventually what I did wasn't necessary, I shouldn't have done that. Okay.
And
I don't know why I took the difference. I was just trying to think more on a mathematical intuition. But anyways.
I'm not sure what I did there. I should restart my kernel. So we did something that's too high, something that is equivalent, and then we can do something that's too low. Yeah. Okay, yeah.
What's the difference between having else and else as a last one?
So there is no difference. We can do an elif guess is less than secret. That would the program would work just the same. The else is just quicker because we know there are no other options here.
Why wouldn't you allow if statement?
We could also, in this particular case, we could also put a bunch of if statements in a row, but then we'd have to be careful that they are mutually exclusive. So like in the previous example, right, if we have a bunch of conditions that might all be true, all those ifs will execute. Right? That's the thing, because the if starts a block. The elif is just associated with that block. So either you do one or the other or the other. But if you have a whole bunch of ifs, then they might all be true and they'll all be executed. Yeah. Yeah.
Why don't we use parentheses with if and else statements?
Oh, we could use parentheses in the if-else statements. You mean like this? Yeah, we can do that, especially if we have a whole bunch of expressions together. But if there's just one, Python will automatically know to do the expression first and then do the if. Yeah. These are all wonderful questions, by the way. Okay. So as we saw, there was a little bug in our code. It's a good thing we ran it. I should have run it with a bunch of different options, but it's important to debug early and debug often just to make sure that you don't introduce a bug that will kind of carry on throughout the code. That's another big idea. And then a quick summary of what we've learned. Input and outputs obviously make our programs interactive. We added branching as a way to introduce decision points in our program. And next time we're going to do a little bit more branching and then introduce looping, so ways to repeat commands in our programs. Sorry I went a little bit over time. I won't do that again.
All right, so our lecture is ended. Okay.